Now, on the previous page, we looked at if we change the 95% confidence interval to a 90%, or sorry, yeah, 90% confidence interval. But now we'll look at what if we want to change it to a 99% confidence interval. We want to be very confident that the population proportion is somewhere in our confidence interval. In statistical practice, the most common confidence intervals are the ones we talked about on the previous page, 90%, 95%, which we've been really talking about a lot, and now 99%. It depends on the situation, but sometimes you might want to be very, very confident that the true population proportion is actually in your confidence interval. So you would want to make it 99%. But other times you're not really worried about if it's exactly in there, or it may not be. So 90% is good enough for some situations. For the 99% confidence interval, the z-score is 2.58. Why? Because the central 99% of the area under a normal curve lies between those two z-scores. Z equals, and that's something you wouldn't probably calculate by hand in real life. You would just use an applet or look it up in a table or something. Yeah, it's hard to tell. It looks like all the area beneath this curve is green, but there's really just a little bit of area, just 1% of it is distributed between the very left and the very right side beneath the curve, but 99% of the area is under that. And the cutoff is a z-score of negative 2.58 and a z-score of positive 2.58. So let's look at an example where we want to calculate a 99% confidence interval. The following is an excerpt from the August 2011 Just the Facts publication from the Public Policy Institute for California. The quote, because neither the majority of political parties has a majority of California registered voters, independents are influenced in statewide elections. For example, in the previous gubernatorial election, 52% of the independents in our post-election survey said that they voted for the Republican Arnold Schwarzenegger. But in the 2008 presidential election, most independents, 59% of them, said that they supported Democrat Barack Obama. In each case, the outcome reflected the choice of the majority of independents. Suppose that the survey included 1,011 randomly selected independents, so someone that's not registered Republican or registered Democrat. Find and interpret the 99% confidence interval for the proportion of California independents who supported Barack Obama in the 2008 presidential election. Okay, we'll check the conditions to make sure that this is, we could assume that this is a normal distribution. Okay. Again, we don't know the population proportion, so we're going to have to use the sample proportion that was given to estimate it. So, okay, check the conditions for using a normal model. They're easily met with such a large random sample. If this was a small random sample, we might not meet the conditions, so we couldn't do it. We just say, can't do it, stop, all done. But this one, I think it's going to work. 59% of those 1,101 supported Barack Obama, defined as a success. 650, the rest of the 1,101, so 1,101 is the total number. To find the 650, we just multiplied the total number of people by 59% or 0.59. So 0.59 times 1,101 is about, you might have gotten a decimal when you multiply those, but you can't have a decimal amount of a person. So we always round it to a whole number because we're talking about people, not parts of people. The rest of the 1,101 did not support Barack Obama, defined as a failure. And again, we're not saying that this is actually a success and this is actually a failure. They're just saying we're measuring how many supported this candidate because that's what we're measuring. We say that's a success. We could have easily said the opposite. How many did not vote for Barack Obama, and that would have been a success, and actually voting would have been a failure. So no, never think that when we say success and failure, we're trying to say something's good or bad, like they mentioned on a previous page. So the number that did not support Barack Obama was the total 1,101 minus 650, which is 451. We'll find the confidence interval. In this case, we want to find it with 99% certainty. So we said the z-score for 99% confidence interval was 2.58. And that's, something that you wouldn't have to calculate. You just look that up in a table or applet. So we take our p-hat, which is 0.59. That was given. 59% of them supported Barack Obama, plus or minus that z-score, 2.58 times that formula we know and love, p times, or square root of, I should say, square root of p times 1 minus p all over n in the square root. The sample size is 1,011. That's, I think they might have messed this up. This should be 1,011, not 1,101. Oh, well, they put the 0 and the 1 in the wrong place. What are you going to do? Yeah, and then you calculate that. 0.59 plus or minus 2.58 times that big square root formula. It looks like they simplified that square root formula. When you calculate that, you get 0.015. If I multiply that by 2, 0.015 times that 2, the red 2.58, I get 0.04 if you round it. I need to add and subtract that from 0.59. So the smaller number will be 0.5, smaller number in our confidence interval, 0.59 minus 0.04, and comma, the larger one will be 0.59 plus 0.04. And it looks like those are the numbers we get. We get 0.55 as a smaller number, comma, the larger number, 0.63. So between 55 and 63% of California's independent voters supported Barack Obama in 2008, and we are 99% confident that that's the case. So it's a larger interval, like we said on the previous page. If I didn't really need to be 99% confident, for some reason I was good with 95% confident or just 90% confident, this interval could have been narrowed down into a smaller interval. So it would really narrow down the choices for the population proportion estimate, but I'd be less confident that the number's actually in there. So like I said, there's kind of a trade-off here. The confidence interval formula, just to kind of reiterate, since we no longer restricting our confidence interval to 95%, we're not going to use the 2 in front of the square root exactly anymore. The 2 was only because we were focusing on the 95% confidence interval level. But now, because we might change it to 99, we might change it to 90, or even something else if we're feeling crazy, we're just going to keep it simple. So remember that the p hat is the sample proportion. The z with the little c just represents the z-score for the confidence level, I guess. So just depending on which level you want, 99%, 95%, 90%, depending, you would look up that appropriate z-score. Which one are you focused on? Look that up for that percentage, or use an applet or something. Let's see, then we always use the positive z-score. Yeah. Technology often uses 3 decimal places. If we use the negative z-score, it would work fine. It's just putting a negative in there makes makes it a little harder. So we might as well use the positive one, but either one would actually work. For our most common confidence levels, the values of ZC are these things. So for 90% confidence, we saw this on the previous page, the z-score is 1.645. I think we rounded it to 1.65, which is fine. And then the 95% confidence level was 1.96, which we kept using 2. That's a rough estimate of 1.96. They just made our calculations easier and us writing our work easier. And now we've seen in this page, 99% confidence level has 2.576 as the z-score.